Today, I'm going to give you a very quick summary about the periodic table, something which you should have learned since Sec 1. Now, the periodic table, as you know it, right, consists of elements. Not just any elements and arranged in anyhow, but all the elements that has been discovered, arranged in increasing proton number. Which means if you encounter a test question that tells you, for example, you have an element X, Y, Z arranged in consecutive, and they are consecutive elements, if they are consecutive elements in the periodic table, right, it means that they have a difference of only one proton number. This is because elements, okay, elements is only different, okay, it's only one proton number more than the element just before it. So which means in this case here, if somehow through other ways I establish that X is actually your lithium, if you observe your periodic table, right, the next one after lithium would be, you should then be able to straight away tell me this is beryllium, okay, and Z would then be your boron, okay, because they are consecutive. So this is one of the ways that your exam question can actually come out. Okay, as you guys have known it, the periodic table, right, have columns, which they call group, as well as rows, which they call a period. Okay, in a very same group, right, what happens is in the same group, if the elements are all in the same group, you can very clearly tell me that they will have the same number of valence electrons. Now, valence electrons are what we also call as outer electrons, okay? Outermost. Which means that in this case here, same number of valence electrons. So in group 1, one valence electron. Now, because valence electrons are what determine chemical properties, this means that number one, if they have the same number of chemical valence electrons, they will have the same chemical, okay, same chemical properties. Okay, they will have the same chemical properties. Number two, because they are in the same group, that means they will also form ions of the same charge. So there you have it, number one and number two. Simply because they have the same number of valence electrons, and you know they have the same number of electrons because they are from the same group. Now, for the elements, right, as we move down the group, you observe that they have, okay, a tendency to lose the outermost electrons more easily, okay? As we move down the group, there's an increase, okay, tendency to lose your valence electrons. Why is this so? Okay, this is so, okay, because, okay, of the further distance, further distance of valence electrons from the nucleus. Increased tendency to lose valence electrons because of the further distance, okay, of valence electrons from the nucleus. What do I mean? Now, take a look at an example for me. Lithium, okay, group 1, second period. Now, your lithium has only 2 electron shelves. The outermost electrons is only 1 shelf away from the nucleus. If we move down, lithium, sodium, K, the next one, which is your potassium, linear K, potassium. Okay, now potassium is in period 3. Okay, no, period 4 to be precise. So in this case here, you have 4, okay, electron shelf. Okay, yes, potassium is in period 4. That means in this case here, potassium you have 1, 2, 3, 4. Okay, this is of sodium and this is of potassium. Potassium, outermost electron will be 1, 2. Okay, 2 shelves away. That means in this case here, it has a higher tendency for your potassium to lose these valence electrons because of the further distance of the valence electrons from the nucleus. So that's the reason why, trend down the group, you will tend to observe this. Now, when it comes to period, right, we do the same approach. Elements in the same period, okay? If the elements is in the same period, they would have the same number, okay, of, not valence shelf, but they have the same number of valence electrons. Sorry, they have the same number, excuse me, they have the same number of electron shelves, okay? Same number of electron shelves. Okay, same number of electron shells. So as we move across the period, in the same way there's a trend. In this case, as we move across the period, you will find there will be a decrease in metallic properties and an increase, okay, in non-metallic properties. Okay, so which brings us next. This is a really straightforward trend. Now, which brings us to this phenomenon here. If you look with me, right, boron, if you take boron and you move 3 diagonal downs, you'll find that this line here is really the line that actually so-called separates metals from non-metals. But the issue here, student, is this. These elements, okay, here, this one here, this one here, this one here. Okay, so if you guys tend to forget this, right, just remember it's boron, 3 down, and out of these 3, right, 1, 2, 3, the one directly down. Okay, all these guys, okay, are what we call metalloids. Now, metalloids are elements that displays both metallic as well as non-metallic properties. If you guys are ever asked to give me one example, you can say silicon. Okay, so this will be one example of a metalloid. Now, students, before I close this summary, I just want to draw your attention to one metal, which is aluminium. Okay, now, aluminium is a metal. And you know that metals, if they form oxide, they are supposed, okay, metals are supposed to give you basic oxides. Now, the one next to aluminium, right, is silicon. Now, silicon, right, what happens is it's non-metal, although it's a metalloid. Now, if we want to be really sure, we bring, instead of silicon, what's one to the, okay, silicon, right, over here, I will have phosphorus. Now, phosphorus, okay, if it forms, is a non-metal. And you all know that non-metals, right, should by right give you acidic oxide. Now here's the thing, metals give basic oxide, non-metals give acidic oxide. Basic oxide reacts with acid, acidic oxide reacts with bases. Aluminium, being a metal, by right should give me a basic oxide. But however, lo and behold, aluminium, okay, when it forms oxide, it forms amphoteric. It's an amphoteric oxide. Which means, in this case here, aluminium, when it forms oxide, aluminum oxide, it can react with both acid and bases. And this is one very fine example, okay, of how metallic properties, the blurring in that sense of metallic and non-metallic properties as we approach the Hayes-McDaniel line. And that is a summary of the periodic table for 16.1 and 16.2. Thank you.